Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, well, I'm trying to fix this thing. This is my ZOYI ZT-703S. It's a multimeter, it's an oscilloscope, 2-channel. I've used this for quite a long time on the channel. It was very inexpensive. I think it was about $80. I've had it for maybe about a year or so. And one of the channels on the oscilloscope is dead. And the worst thing about this is I think it's been kind of failing for a while, and I kept blaming my probes. And I was using this the other day, and it just didn't seem to be working properly. And I was using this probe, which is an old Ballantine probe that I've had forever. And I assumed it was this that was the problem. And I actually kind of started taking apart the end of the probe here, and it used to have sort of a plastic ring around the BNC jack. That's gone now. Well, that wasn't the problem. The problem was this the whole time. So I want to try to open this up and see if I can get this working, but first I'll demonstrate what exactly is wrong with this. So it goes without saying, this is a cheap device, and I don't expect it to be perfect and work perfectly, but I do find that I rely on this thing. I use it all the time, and I think I really like it because it's rechargeable, USB-C. This little flap, it sucks. In fact, I should just rip this off, to be honest. Yeah, this is just dumb. Okay, take that off. Anyways, USB-C rechargeable, and it's just, I like this thing. I like the form factor, but it's just unfortunate because it's obviously built to a cost. Well, there's obviously something that went terribly wrong with the BNC input jack. First, I'm gonna plug this into channel 2, which does seem to still work. And even though I kind of destroyed my probe, I still can use it. To demonstrate the fault, this is experience, I'm going to plug this into my frequency generator on the bench. The virtual bench from National Instruments is what I'm going to be using. This is, well, the only real frequency generator I have. I have another small one, but this thing is capable enough. So we'll turn this on 1 megahertz, 5 volts peak to peak, DC offset is 2.5. That just means it's a sine wave because there's the output, sine wave. And actually, let's just switch this to square wave since that's more like a signal we'll be measuring off a CPU or something like that. Okay, so there is our signal. I remember I'm on channel 2 right now. We can tell if I just push menu, channel 1 is currently off. Channel 2, there we go. Channel 2 is currently on DC coupling 10x probe. Let's exit the menu and we can speed this up. Oops, wrong direction. So there is our square wave. How do I turn on the measurements? I think they are on right now, but they're only on for channel 2. So trigger source is channel 2. The user interface on this could be a little bit better. I've kind of gotten used to it, but some of the features like where the measurement stuff is, I still struggle to find it. Measure, here it is. Okay, so it's currently measuring on channel 1, as I mentioned. So we want to turn this stuff off. So we want to do frequency. There we go. Exit. There we go. Oh, that's so annoying how it's over here. The channel 1 measurement box is over there. I guess they wanted to align it with the channel 2 indicator, but when we're not using channel 1, that's just stupid. That should just be over here. Anyways, there's our 1 megahertz, peak to peak, close enough. As you can see, it's updating nicely, and that's why I like this thing. It has a pretty good update rate. Let me go into the virtual bench interface, and I am going to manipulate the settings a little bit, just so you can kind of see it moves up and down pretty smoothly. And we'll change the speed. So there are 2 megahertz. And this is using what it has on screen for measurement, the frequency. It's not a hardware frequency counter, which is why it has lost the ability to count now. You have to kind of zoom in to have it work properly. This thing works. I like it. I like it because it's portable. I can throw it in my bag. I don't really care too much about it. But as I've always said with test equipment, it needs to freaking work, because if this thing is malfunctioning, which the problem is I'm going to connect it up to a motherboard or whatever under test, and I'm going to assume the motherboard has a fault. And you waste a ton of time chasing your tail to go, oh, wait a second, it's the freaking test equipment that's the problem. So there's something to be said about buying a quality instrument, which this isn't really exactly a quality instrument because, yeah, you can have problems like this. Anyways, let's unplug this and we'll move over to channel 1. Okay, so we gotta, so first off, we'll turn off channel 2. Okay, well, you have to have at least 1 channel on. There we go. So this is channel, let's go back to channel 1, DC coupling, 10x probe, all the same, and yet, what is this? Clearly, there's a problem here. So what's happening here is this yellow mark, if I just move this up to this middle line, this is the 0 point of the waveform. So we know this waveform is basically going from 0 up to 5 volts, and we're at 1 volts per division. So these are the divisions there. Well, this screams right here that there's no ground reference. Now what we can do is move the trigger point down so this will be updating more quickly. And let's jiggle this around. So that doesn't really make it any better. And this is what it was doing last night, or, you know, I just had like really inconsistent signals and I just assumed it was my probe that was the problem. But obviously it's not, because you saw on channel 2 works perfectly. So everyone can see that this is the case, we'll just turn on both channels simultaneously. And again, just want to show channel 1 is enabled, DC coupling, 10x probe, channel 2, exactly the same settings. I mean, all the rest of the settings in here, it's just the trigger mode and stuff like that. It is triggering off channel 1 right now. That's because the trigger mode will automatically change to, if you only have one of the channels enabled, that automatically changes. Okay, let's move the 2 channels so they're overlapping exactly. And let me move this over to, oh, so what's going on? You see that? It was moving around, but we can plug this into the other channel now. And there we go. It's not triggering because of course triggering is on channel 1 right now, but notice the waveform is all above the 0 point, so that's working as it should. And we put it back on here and there we go, same thing. Anyway, so that's the problem. There's something wrong inside. My feeling is you can see the kind of wear that's happened around this jack. Look how this moves. This one doesn't really move. So obviously we have a physical problem inside here. I doubt there's an electrical issue. This is just some kind of physical problem. So what we need to do is we need to open this thing up. And hopefully it's just a cracked solder joint or something that I can fix relatively easily. I mean, these aren't that expensive, so I could just buy a new one, but I don't feel like buying a new one. And one of the things I have not done with this ZOYI is I have never opened it up, actually. From my understanding, there is, just this screwdriver barely fits inside the hole there. From my understanding, there's actually an 18650 or 2 18650 batteries in here. So that's nice from a user serviceability standpoint. So if the battery ever kind of gives up the ghost and stops working properly, that'll be nice to be able to easily replace it. Incidentally, underneath the tilting bail, there's nothing. There's no battery compartment or anything like that. So let's get this apart. I'm assuming just 4 screws, and it should come apart somehow. It's got like a fake cover on here. This rubber here is not actually something that like you could take off. So my assumption is this thing will just split apart. I think there are some clips or something in the middle section here because it doesn't, it sort of starts to peel apart top and the bottom, but on the side it is holding on for dear life. So time to get a spudger. Okay, there we go. Yeah, it looks like there's one clip there. I just ran this down that seam. Let's try the same on this side. There it is. Cool. Okay, one 18650 in a holder. How convenient is that? Now the front end for the scope is up there. So let's figure out, oh, it's all soldered together. So of course it's not going to be as easy as I had hoped. It's not entirely soldered, but at least it is up at the top there. Okay, well, I got nothing to lose. Let's take this thing apart the rest of the way. I don't really care specifically about super duper accuracy. Let's get this battery out of here. Anyhow, as I was saying, I don't really care about the accuracy of this device. Sometimes taking them apart, you know, if this was like some kind of high frequency calibrated thing, then going inside the front end could potentially cause some issues. Now, I haven't had any other issues with this besides what I've just demonstrated here. It's been a pretty trusty device. There's also been a number of firmware updates and it has improved a bunch of the capabilities, which is always very pleasing. Stuff like when you are in the multimeter mode and you're doing continuity or, you know, one of the checks like AC, DC, but specifically if you're in like the continuity beeper versus the diode check, when you turn this off, turn it back on, it goes back to where you last had it. That is a big deal to me. It bugs me when these digital multimeters kind of default to a specific mode and you shut them off and you turn it back on and then that mode is gone, especially if it's gone to sleep due to a power saving timeout. Well, this thing used to do that. We're just going to go back to whatever the default was. I think I got to take these screws out for the multimeter there. Okay, there we go. This is coming out. Okay, so the screen is a separate module. So I'm going to try to disconnect this. Let's get these little plastic pieces off. Okay, that part's there. This has a little flapper there. See the ribbon cable? So let's see how this works. Does this have a flip down lever? Can never tell. Well, look at, yep, there we go. Flip down lever. And that ribbon cable should slide out. Okay, I didn't want to take the screen out, just leave it in there. That way dust doesn't go inside. Okay, there's a spacer. There's the ribbon cable. And here's our board. So they rubbed off the part number on that. I don't know if this is an FPGA or CPLD or what, but that's probably handling the oscilloscope. Oh yeah, they've really gone to town removing all the markings on these chips. I'm sure this is not the first time someone has torn one of these down. But yeah, none of these have markings. That has a marking on it. You can barely read it. But those are rubbed off. That's rubbed off. Lots of things are rubbed off. Anyways, our problem is going to be inside of here. So we got to get underneath, at the minimum, under this can. And looking at the top side, there's a blob of solder there. And a blob there. That's it. That appears to be the only two places. Yep. Okay, that's all. So I'm going to have to get that cleaned off. Let's use some braid. And let me warm up the soldering iron. Okay, I think that released the corner. Yeah, that corner's off. So the braid works well for this. It would work better than actually trying to use my Hakko desoldering iron. And using a little offcut like this is a good idea. It gets warmer more quickly. And then you don't burn your fingers if you use a tweezer to hold on to it. All right, I think this might be free. Yes, there it is. And the bottom should just come off. I think there are maybe there were tabs. Looks like we have a couple trimmers. Trimmer there. These are relays. So this is going to be the digital analog converter. Yeah, it uses a single one for both of these. So it's going to multiplex, I assume. So you'll have half the bandwidth when you are going through, both channels simultaneously. I'm noticing on this side, they, save those pennies by applying solder there and there to the top can, but, not there. Don't need it there. Just do it on the 2. 2 is good. 3, too much work. They also sort of cheaped out by not even bothering to solder the bottom can on at all, although something's holding it on. So it looks like there's a tab right there that did get a little bit of solder on it. Sorry, it's out of focus. Right there, sort of keeping it from coming up. And the same on this side. I think next to that little component there. All right, so I think the problem is here is, see the blob right there and right there? I think that is actually, okay, well that one's not, but I think over here where that blob is, I think there's a slot underneath that. Okay, making progress. So it wasn't the little pad there. There was a little tiny hole right next to it, and that is where it was actually connected. And there's going to be something similar on the other side somewhere. There it is. It's right there. It's that blob that's holding on this side. There we go. That is free. So if we take a look at this little plate, you can see channel 1 is this one on the left. And do I see an issue under here? No, I do not. So yeah, that's kind of curious. I don't see broken joints. Maybe I can probe around a little bit. So this multimeter is a good example of one that's annoying. So it's in the beeper mode right now. See, like that. But if we turn it off or goes to sleep, and it goes to sleep very quickly, it comes right back, and it always goes back to just regular ohms. So you have to wake it up and then push this button. So yeah, this one does not do that after the firmware updates. Okay, first off, let's see if these have continuity. No, they do not. They definitely should, because if we look here, these big ground lugs, these do have continuity, and yet that does not. And then I think let's see how this works. Okay, I see. So there's like a center conductor, because this is a coax input. And incidentally, I made a mistake earlier. I said that this was channel 1, that is channel 2, because this actually goes on like that. So there it is, channel 1. This is the broken one over on this side. So for instance, if we go here and we check these lugs, we have a connection. We go here, no connection. So it's actually the jack itself that's broken. It is not a bad solder joint. And let's see here. Okay, so the outside ground also makes its way right to there. These are the 2 pins that are the coax, the actual signal itself. That's the center conductor. And then that's the outside. And if we go over here, yep, same problem. So The outside is not connected at all to any of that. So there's something wrong with that physical jack. You know what? I see what the problem is. Notice where this nub is. Look at this one. It's twisted. And remember, this goes on this way. So channel 2 is correct. The little nub is up at the top, but this one is off to the side. And I know why this twisted. This failure happened because this probe originally had an extra little pin that stuck out of it that was for, I think it was like a sense pin for this on certain oscilloscopes. Well, look at this. Look at this plastic piece. Look how you can see where that pin has dug into this. And this is like a soft plastic. See how it's like a sticker? And the nubs should be straight up and down. Well, I guess from twisting this just to get that thing off, it was so difficult. It actually physically damaged the jack. So I need to go and see if I can find like a scrap board that has one of these jacks on it and transfer it over. Because I have a feeling what happened is when it twisted, it broke the ground lug there right off of it. Let me try to get it off first. I need to do this carefully without like dislodging any of these little components. So yeah, good luck here. Yeah, that's not supposed to happen. That was the ground pin. That just came off entirely. So that was completely broken. Of course, getting this off is really difficult because I don't have the right size nozzle to get over these large pins, and this is all on the ground plane, so it's really difficult. So I'm just trying to heat this up one at a time. Try to get this out of here, and I got to do it in a way that doesn't dislodge any of those nearby components. Feels like it is so ready to come out right now. There we go. Okay, well, it doesn't look like there's any damage on the board. This was just physically damaged, and these jacks are just not suitable for the rigors of, well, constantly connecting and disconnecting them. And yeah, it just twisted in the body, and that just ripped that pin out. Okay, well, now I need to see if I can find another one of these. I gotta have someone around somewhere I can steal from. I gotta. All right, a little bit of searching, and I found this. This is a video capture card, PCI. These things are dime a dozen. I'm just gonna steal one of these connectors off of here. Now, people are gonna be like, oh, you're ruining a perfectly good card. It probably does work. But don't worry, these are easy to obtain. I don't need to fix this now, so I'll just order one of these and I'll fix this card later. It should be no problem. It's obviously exactly the same jack, and none of these are twisted. Yeah, they look good. So I'll just steal one of these. So let's take this apart and get one of these jacks off. I have to do the same methodology to get it off as well. Same problems I had before. I used to use these cards back in the day for video capture at a job I worked at, and they're okay. They do a decent job. No time-based corrector or anything like that. And this particular model, I'm pretty sure, is just composite, 4 composite inputs, not even S-video or anything like that. So I'm going to start with the one in the corner here. It's just easier because, of course, there's less thermal mass for the ground plane, and I'm going to use hot air as well. First, I'm just going to try to get all the solder out I can. Did that do the trick, actually? Oh yeah, that's loose already. Well, it's loose, but it's not completely out. So same problem I had with the other one. These lugs are just annoying. So you got to kind of push them out one by one. There we go. This one, go back and forth. Now I already know that these 2 pins are disconnected. They came out easily, but it's a very tight fit for those ground connections. Now that's obviously, I think, part of the structural integrity of the jack, which is why they're so stiff. So you just kind of got to pop them out. There we go. This one, I'm just going to toss out so I don't accidentally try to put it anywhere, like reuse it. Oh, one of the things about this card, by the way, is this does not have like MPEG-2 encoding or any kind of compression. This just sends the raw data directly over the PCI bus. So you need a relatively powerful computer, which is why these aren't that desirable, in my opinion. On the other hand, if you have something that's fast enough, then you could do good quality real-time hardware encoding, but you might have drop frames and stuff. So those cards are not great. Let's clean this up a little bit, just so it goes in a little bit more easily. Oh, Well, that's not what I wanted to have happen. The pin just sort of came out. So I didn't realize these pins are literally just melted into the plastic body. They are not attached at all. The ground pin is connected entirely there. These are just for structural integrity. Okay, well, let's hope that this can go back in. It might not, though. And the reason why is I was trying to clean up those lugs because they're kind of covered in stuff, and to get them into these holes, which is a very tight fit, yeah, I'm gonna have to come up with a solution to make this work a little better. Obviously, if this is a new jack, this is not gonna be a problem. This is only a problem because I'm reusing this and it's covered in some leftover residual solder, and I can't just use the desolder iron to try to clean it up because that melted the thing entirely. So I'm obviously just using my little grinder here just to try to smooth these out so that it will fit in the holes on the board. Okay, I just got it back in. Clicked into place. Yes, that's going to work. And both of the signal pins are in the right position. Okay, let's get this reassembled. Hopefully this fixes it. I can't power this up, obviously, without the screen connected and the membrane keypad. So hopefully this works. I don't see why it won't work, as long as I don't mess up any of the components that are nearby. First, these big lugs. Let's get these on. Now the two signal wires. There you go. I just wanted to show the connection itself. And those are all aligned properly. I suppose, oh, it's actually not in all the way. Whatever. I don't even care. It's good enough. It doesn't really wobble around. I just need to know to be careful with these jacks and not put too much stress on them because it will just break them again. Now it's just a matter of getting this shield stuff back on. Of course, these are really tight fits, the little notches where the little tabs went through. That one does not fit, and I think I just bent it. And what's really difficult about these little tabs is it's super close to little components, and I just have to be so careful. Like there's a little chip there. Huh. Maybe I'll try flowing some fresh solder into it and then cleaning it out. Let's see if I can clean this out now. I mean, it's not perfect, but it's something. I think it's better than it was. Let's see if this goes in there now. Oops, wrong side, obviously. That one works. It's this one that's the trouble. I am basically ready to just chop that tab off and not even bother with it because it is impossible to clean that out. And it's just right next to that tiny chip and a bunch of components. And I just don't care at this point. I really don't care. This is what happens when you're dealing with stuff that's not designed for serviceability. So there we go. I just chopped that tab off entirely. Now this thing will go on there. And then I'll just put a blob of solder on that pad that's right nearby. It should be fine. So there we go, just like that. You can put a blob there. I can put a blob there. In fact, let's just do that right now. 2 blobs, and then that one over here, which I can solder that one on. That would be the tab, although maybe I shouldn't. Maybe I should just, I'm gonna do that blob there. I think the blobs are easier to clear out because you could just use braid to clear them out versus those tabs, which are so frustrating. All right, there we go. 3 blobs holding the bottom one on. Now the top one. And I seem to have a problem putting that blob in, got some solder into the little hole where the tab goes, this tab over on this side. So another tab that is getting chopped off. So I can get this on, just make sure you put your finger there when you chop because it will go flying otherwise. There we go. So now it's on all the way. Yeah, that one little hole for that tab was filled in. Okay, now some more blobs. I don't know why there's an opening right there in the shield. That seems odd to me. I guess there's a reason. Oh, there too. Maybe it's easy manufacturing. I don't know. Okay, the bottom one is held on by 3 blobs and the top one's held on by 2 blobs. One there and one right there. And there's no way to put one there. See, there's a pad there for it, but that cut in the shield prevents that. But either way, hopefully this should work now. Let's take a look at this 18650, 12.58 watt hour. I don't know if that's real or not. 3400 milliamp hour. It doesn't feel light. I mean, it doesn't feel like those air-filled, really cheap crap ones. This would be trivial to put a better one in. So if you have one of these and the battery life isn't doing so great, then swap this out. Goes without saying, assembly is reverse of disassembly. I'm really struggling to get this LCD back on. The ribbon cable is just thin as tissue paper, and it is just very difficult to get aligned into the connector. I think I got it. Wow, that sucked. Okay, I think it's in there. Now, part of the problem is I need to make sure there's no dust on there, so let me get a little duster thingy. I think I got one somewhere. All right, I can't find it, so we're going to use this. So that goes in like that. This little spacer goes in underneath. There we go. So that is in there. Once I have the screws in for these lugs, I guess I should put some in for the actual board, then we can try turning it on before I put the back cover on at least. Of course, going into plastic, you want to go backwards until you hear a little click, and then I'm going to keep them all loose again until I have them all in. One thing I'm noticing, there's a 4-pin header right there. I wonder if that's for programming. We don't know what kind of devices these are, unless someone's already reverse engineered the firmware on this, which maybe has happened. I thought I saw maybe an open source firmware for this, but I can't remember. I'm keeping all the screws loose, like I said, and it looks like there's 2 more right down here by the multimeter section. Go backwards till you hear a click. Back it out a little bit so it's loose. And then we'll tighten them all. Okay, so this doesn't move around at all. So I guess it's a pretty tight fit. So now I'll just torque the fasteners. It's all just into plastic, so I don't need to do it too much. Don't want to break anything. Okay, and these middle ones. I'm sure everyone is on the edge of their seat waiting to see if this thing works. Okay, there we go. Turns on. That's something. Let's see, this should be working right now. So channel 1 is this one. There it is. The yellow trace fixed. Freaking awesome. Let's move the trigger point into a proper spot in the middle. And channel 2, this one, looks good as well. So I've had some problems in the past, I think, with some of the cheap probes, like the ones that came with this. Let me see if I can find one here. These are 100X. I don't know, I must have thrown them out because I was angry. Or maybe this is one right here. Okay, this is one right here. This is a 10X, 1X. I've had issues with these where it just had not a great connection. Let's see if this thing works. Plug this into the signal generator. It's fine. So I don't know if that jack had been failing for a while, or if, yeah, I think the problem was with the cheap probes and the actual BNC jack that's on the cheap probe. I don't think it was this one. I think the cheap ones I threw away because I was so angry that they were messing up. And that's why I went and got my Valentine probe out. It just had that pin, which then, as I showed, dug into the plastic, into this, and then caused it to have a problem where it ripped the jack. I think that came later. Because once I moved to this, before I damaged the jack, everything was working fine on here. We didn't have any bad connections. But this seems fine too. Let's switch to the other one. Uh-oh. Oh, it fell out of the signal generator output. There it is. Looking good. Okay, cool. So no damage was done. It doesn't seem like any damage was done to the input stages when I was fiddling around getting this cover off. Awesome. Okay, let's turn this off. And I just need to do the final reassembly. Hopefully I didn't, yes, I made a mistake. I needed to have put that on before I screwed the board in. Okay, I'm gonna go take this thing out again and fit these plastic pieces in so I can get this thing all back together. All right, there we go. These are both in. You gotta put those in before you slide the board in. And I'm just gonna write on here, let's see, channel 1, new BNC, 15th of April, 2026. There we go. This thing will live another day. That makes me happy. I mean, it wasn't like it was that expensive of a device, but hey, if we could fix something versus just throwing it away and buying a new one, isn't that a win? I would say so. Same thing as before, plastic screws, you got to go backwards until you hear a click, then start threading it in so you don't create new threads, although who cares if I did really. And then of course this has plastic clips, so we got to push it together. There we go. And now we can fasten these the rest of the way. And there we are, booted right up. Let's connect this. Look at that, looks good. And the other one looks good as well. Nice, okay. Fully operational. So there we have it. ZOYI ZT-703S lives again. It totally seems to work again. And that makes me happy because yeah, it's better to fix stuff right than throw it away. And while I have another battery powered scope, I think the Handtech, whatever the model number is, I like this one way more. The interface on this is just so much easier to use than the Handtech. It's just a better device. Not to mention the screen is bigger on this. The update rate is faster on this. It's just better. Now, there may be better small battery powered scopes out there. I have only tested 2, this one and the Handtech, but for the $80 this is, I think it's really well worth it. Maybe there's better ones now. This is what, a year old, or maybe it's older than that at this point. Maybe there are better ones, but this thing can realistically work up to like 30 megahertz, and do a decent job. I wish it had a hardware frequency counter like the Rigol, my Rigol scope does, simply because relying on the little measurement thing here is just based on what's on screen, and I'd rather have more accurate measurements, but it's good enough to get a feel for like, oh, it's running at 1 megahertz, that's correct, versus like, the clock frequency is way out. And the other good thing about this for me is that the screen, while it is kind of glary, maybe I should buy like one of those anti-glare stickers that you get for like your phones or whatever, and then I could just cut it out and stick it on here. But for filming, this thing does a great job. The screen is really readable, and it's so much more readable as long as, I keep the glare away than a standard LCD, reflective LCD screen, like on a normal multimeter. So if I'm in the multimeter mode, the numbers are nice and big, and I like that a lot for filming, compared to something like this, that is. So hopefully this video was interesting. I was able to take a part off this, 2003 capture card and put it in this scope that's only a year old. So it just shows how little some parts change. And I guess the nice thing about this is, yeah, it is off the shelf parts. If this were made by one of the bigger manufacturers, I bet you the BNC jacks would be somehow proprietary and you couldn't just, swap them in. But then they'd probably be more robust as well, and it wouldn't have broken like this one did. So I need to be very careful not to put too much force on these, because really there's nothing holding those in except for those 2 lugs, the ones that melted out. And then the jack itself could easily just twist like it did, and then just rip those 2 little thin metal contacts that connect it up. But there we go, back to operation. So if you liked this video, thumbs up. If you didn't, you know exactly what to do. Huge thanks to my supporters, all the usual YouTube stuff, and that's gonna be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.